Yeah, good morning, students. In the previous classroom discussion, we had a discussion on insertion and selection sort techniques. Right? In today's classroom discussion, we had another important sorting technique, that is the shell sort we are going to discuss. So now I would like to share my screen. One minute. So shell sort. This is week 11, lecture 3. Hope my slides are visible to you. So classroom discussion topic 33, week 11, lecture 3, shell sort. So summary of the previous CDT is that we had a discussion on selection sort technique. So which is a sorting technique that has a time complexity of order of n square, thereby making inefficient to be used on large data sets. The selection sort technique finds the smallest value in the array and places it in the first position. Then find the second smallest value in the array and places it in the second position. This procedure will be repeated until the entire array is sorted. So insertion sort is very simple sorting technique in which the sorted array is built one element at a time. The main idea behind the insertion sort is that it inserts each item into the proper place in the array. To save memory, most implementations of the insertion sort algorithm work by moving the current data element past the already sorted values and repeatedly interchanging it with the preceding value until it is in its correct place. Now, in today's discussion topic, the objective of the today's session is that this session will develop the knowledge on shell sort technique. Lecture outcome is that upon completion of this CDT, students are able to implement the shell sort method. So, what is a shell sort here? Shell sort is the generalization of insertion sort, so which overcomes the drawback of insertion sort by comparing elements separated by a gap of several positions. It is a sorting algorithm that is an extended version of insertion sort. Shell sort has improved the average time complexity of insertion sort. As similar to insertion sort, it is comparison based and in place sorting algorithm. Shell sort is efficient for medium sized data sets. In insertion sort, at a time, elements can be moved ahead by one position only. So, to move an element to a far away position, many movements are required that increases the algorithm's execution time. But shell sort overcomes this drawback of insertion sort. It allows the movement and swapping of far away elements as well. This algorithm first sorts the elements that are far away from each other, then it is subsequently reduces the gap between them. So this gap is called it as an interval. For example, you consider this as the elements in the given array. So using original sequence of shell sort for n by 2, n by 4 and so on up to 1 as the interval we will take it as, that is a gap we will take it as. So in the first loop n is equal to 8 size of the array. So the elements are lying at the interval of n by 2, which is equal to 8 by 2, and 8 by 2 is equal to 4. So elements will be compared and swapped if they are not in the order. That is the gap of 4. The first loop, the element at the 0th position will be compared with the element at the 4th position. If the 0th element is greater, it will be swapped with the element at the 4th position. Otherwise, it remains the same. So this process will continue for the remaining elements. So at the interval of 4, sublists like 33 and 12 compared, 31, 17 compared, 40, 25 compared, 8 and 42 compared. So this is 0, 1, 2, 3, 4. 33 and 12 is get compared here, and then 31 and 17 is get compared, 40 and 25 is get compared, and 8 and 42 compared. Okay, so if they are in the required, now we have to compare the values in every sublist. After comparing, we have to swap them if required in the original array. After comparing and swapping, the updated array will look like this. Fine. So this is what the updater array after pass 1. So in the second loop, elements are lying at the interval n by 4. That is nothing but 8 by 4, which is equal to 2. So that is two elements. Now we are taking the gap interval of 2 to sort the rest of the array. With an interval of 2, two sublets will be generated. So 12, 25, 33, and 40. And at interval of 17 and then 8, 31, and 42. So here what we will do here is 12 is get compared with 25, 17 is get compared with 8, and 33 is get compared with 40, and 31 is get compared with 42. So if they are not in the required order, you will swap it. So after that, now we again have to compare the values in every sub list. After comparing, we have to swap them if required in the original array. So after comparing and swapping, the updated array will look like this. Fine. So in the third loop, elements are lying at the interval of 1, that is n by 8, which is equal to 8 by 8 is equal to 1. So this is nothing but we use the interval of value 1, gap of value 1 to sort the rest of the array elements. So in this step, shell sort will make uses of insertion sort to sort array elements. So that is nothing but here we are going to do like this basically. So finally we are going to get it as the sorted array. So 12 and 8 compared, so 8 is placed before 12, 25, okay, then 17 is replaced with 25, and 25 33, then 31 is replaced with okay, 33, then 40 and 42. This is what the sorted array we are going to get finally. So this is a program, you can go and refer this program. So before sorting what is the array, then we are calling a shell sort by passing array a and total number of elements n, and then we are printing that array. So the function for shell sort will be like this here, rearranging the array elements at n by 2, n by 4, and so on up to 1 intervals. So interval is equal to n by 2, interval greater than 0, then interval is equal to n by 2 becomes n by 4, n by 4 becomes n by, okay, so 8 like that. So outer loop will be for intervals, inner loop will be int I is equal to interval I less than n, I plus equal to 1. Store a of I element to the temporary variable, and then we are making use of this for loop for exchanging and comparing that. So what is the time complexity of cell sort in best, average, and worst case? This is the reflection smart question. So if you are not able to answer this question, please watch this video from the beginning. So LO's lecture outcomes are revisited here. After completion of the session, students will able to develop the code for implementation of the cell sort. And the summary of this today's session is that to visualize the way in which cell sort works, we are performing the following two steps. First step, arrange the elements of the array in the form of a table and sort the columns using insertion sort. So the step 2 is repeat step 1 each time with a smaller number of longer columns in such a way that at the end there is only one column of data to be sorted. Lecture level practice problem, compare the implementation of cell sort with insertion sort and bubble sort. So these are further readings, and then thank you for your patient listening.